Hello everybody, I am Ravi on Maths Rav. Today we are going to study rules of indices from the first topic of C1 mathematics, that is algebra and functions. Let's take a simple example. Let's multiply 2 to the power 3 multiply 2 to the power 2. 2 to the power 3 means we have to multiply 2 3 times, and 2 square means we have to multiply 2 times. If you multiply 2 3 times and 2 times, it will be 64, and we know 64 can be written as 2 to the power 5. So what we are saying is, if we multiply a number having different powers and the same base, or the same powers and the same base, the base must be same. Here the base is 2 and the power is 3 and 2. So the resultant will be 5. You can see easily it is 3 plus 2. In the same way, if we multiply 3 to the power 2 and 3 to the power 4, that is 1 and 2, and this is 1, 2 and 3, 4. So it will be 3 to the power 4 and 2, it will be 6, and that is 729. 3 to the power 6 is 729. In the same way, if we multiply 2 to the power 10 and 2 to the power 15, we need not to write 2 10 times and then 2 15 times. We can simply add these powers. So our answer will be 2 to the power 10 plus 15. So our answer is 2 to the power 25. So now we have to come to the conclusion, that is the first rule of indices, that if we multiply two numbers having same base, we add the powers. Let's take another example. 5 is to the power 3 divided by 5 is to the power 2. So you can see 5 to the power 3 is 5 multiply 5 divided by 5 multiply 5. Power is 2, so we have to multiply it by twice. We can see that we can cancel 5 by 5, so answer will be 5. So in another way, we can write this as 5 is to the power 3 minus 2, that is 5 is to the power 1, so it is 5. So that is the rule number 2. It states that a is to the power m divided by a is to the power n is equal to a is to the power m minus n. Now let's try to solve some of the questions based on these two rules. For example, question number 1, 7 is to the power 7 multiply 7 is to the power 1. So we know that it's a multiplication as the rule 1. So when we multiply the numbers with the same base 7 and 7, we add the powers. So it is 7 is to the power 7 plus 1. So answer will be 7 is to the power 8. Another question, we have a variable here, unknown number, but the same number, the base is same, x and x. The first term is x to the power 3 multiplied by x to the power 5. It's a multiplication rule, so when we multiply the same numbers, we add the powers. So it is 3 plus 5. So that is x to the power 8. Now another question is x square y multiplied by xy square. Here we have to take the like numbers x and x. Here the power of x is 1. So x square multiply x. So x to the power 2 plus 1. And y is having power 1 here. and here the power is 2. So it will be 1 plus 2. So the answer will be x cube y cube. Let's talk about another example. 6x cube divided by, here it's a division. Now one thing you have to understand that these are the constants. So we know that 6 divided 2 is 3. X cube divide x square. So it will be x to the power 3 minus 2. So the answer will be 3x. Another example is 10x to the power 4 divided by 5x square y square. 10 divided by 5 and x to the power 4 and minus 2. 4 and minus 2. And y is to the power, here we have y 0. So the power will be 0 minus 2. So 10 divided 5 is 5. X square y to the power 0 minus 2 is minus 2. Let's take another example. E to the power 3 multiply e to the power 4 multiply e to the power minus 5. We are multiplying all, so we have to add the power. So e will be 3 plus 4 plus minus 5, because here the power is minus 5. This positive number is because it's in multiplication. So e is to the power 7, 3 plus 4, 7, plus minus is minus 5. So the resultant or the answer will be e is to the power 2. Now let's take another example, that is 2 is to the power 3 the whole power 2. It means we have to multiply this number 2 is to the power 3 2 times. So 2 is to the power 3 multiplied 2 is to the power 3. The base is same, so we add the power. So 2 is to the power 3 plus 3, so that is 2 is to the power 9. Sorry, 2 is to the power 3 plus 3 is 2 is to the power 6. Now we can see here that we can directly multiply these powers to get 6. So on the basis of this example, we have another rule, that is third rule of indices. A to the power mn is equal to a to the power m multiply n. We multiply the powers. Let's try to solve this question. 3t square power 3. This is a numerals. We can write it separately. 3 is to the power 3. And then we can write this t square power 3. We know that 3 is to the power 3 is 3 times 3, 9 times 3 is 27. And this t square to the power 3. So what we are going to do, we have to multiply this. 3 times 2 is 6. So it will be t power 6. Another example, we have 4x cube power 3. So in the same way, we have to write 4 cubes separately, and then we have x power 3 power 3. 4 power 3 is 64, and this 3 and 3. So we multiply. Always remember this is a multiplication now here. 3 times 3 is x to the power 9. Now there is a very important rule of the indices, that is, if the power is negative, not the number. I'm not talking about a is to the power m. What we are talking about, a is to the power minus m. Number of type 2 is to the power minus 3, 5 is to the power minus 1, this type of number. So when the power is negative, you have to write the reciprocal. A is to the power minus m is equal to 1 over a to the power m. For example, 3 is to the power minus 2 will not be equal to 2 over 3. This is wrong. Only this number is changing into reciprocal, other number will remain same. 3 is to the power 2 will remain same. So it will be equal to 1 over 3 is to the power 2. That is 1 over 9. Let's do the questions based on this. 16 is to the power minus 1 over 4. Now before we solve this question, I would like you to have this multiplication in your mind. I highly recommend students to know these numbers. That 2 square is 4, 3 square is 9. What number we square to get 16? That is 4. What number we square to get 25? That is 5. So 6 square is 36, 7 square 49, 8 square 64. You must know all these numbers, the square numbers till 19. It's also helpful to know the cube of the numbers from 2 to 10. Because when you get the question of indices, most likely you are going to get these numbers. For example, if you have 125 is to the power 1 over 3. You know there is a number 5. If we cube number 5, we get 125. So you can easily write 5 cube 1 over 3. Always try to find the number which can cancel. So this can be cancelled. So this is 5. That's why these numbers are very important. Other important numbers to remember is 3 is to the power 4, 3 is to the power 5, 4 is to the power 4, 4 is to the power 5, 5 is to the power 4, 5 is to the 5. You need not to remember these numbers, learn you, but you should have an idea. Then if somebody is talking about 81, then it may be the square of 9 or maybe any power of 3. Another important numbers are the powers of 2 from 2 to 10. These numbers are asked most of the time in the question of indices. Now let's come to the question number 1. It's saying 16 and it's saying 16 is to the power 1 over 4. Now we can see one thing. We need any number here whose power 4 is 16. You can see this number. 2 to the power 4 is 16. So we can write 2 to the power 4. Now 4 and 4 can be cancelled. So it will be 2 to the power minus 1. And when the power is minus 1, it will become 1 over 2. This 1 over 2 is not because of this one. This is because of this negative sign. Let's try to simplify this. Another question, that is x. Then we have 2x to the power minus 1 over 4 to the power 4. So we can divide this number. 2 is to the power 4 and x minus 1 is to the power 4. 2 is to the power 4 is 16. X to the power minus 1 over 4 multiply 4. So 4 and 4 can be cancelled. So this is 16 x to the power 1. This x is having 1 power multiply x to the power minus 1. And we know when we multiply the number, we add the power. 1 minus 1 is 0. So 16 x to the power 0. And we know anything power 0 is equal to 1. So 16 multiply 1. So answer of this question will be 16. This question, 25 is to the power 1 over 2. I am leaving for you. You check it here. The hint is this. 25 is 5 square. So it will be a 5 square. You can cancel 2 and 2. Same as this question. 25 can be written as 5 square. We always look for this number. If the power is in a fraction, which number is having that power? For example, 25. Which number is there whose power is 2 equal to 25? That is 5. Multiply minus 3 over 2. You know that the meaning of the bracket is a multiplication. So that is 5 is to the power 2 multiply minus 3 over 2. 2 and 2 cancel is equal to 5 is to the power minus 3. That is 1 over 5 to the power 3. And 1 over 5 to the power 3, you know 5 to the power 3 is from this table, you know it is 125. So its answer is 125. I have some questions for you. 125 is to the power 1 over 3. Simplify and write the answer. Another question, 16 is to the power 1 over 4. You can see where is the number whose power 4 is 16. In the same way you can solve these questions. I have another question that is a bit different type of question. Let's write the fifth root of a is to the power 4, b is to the power minus 3 is equal to a is to the power x multiply b is to the power y. So we have to find the values of x and y. Fifth root, so it can be written as a is to the power 4 multiply b is to the power minus 3. Fifth root means 1 over 5. You must be aware about it. The square root of x is x to the power half. Cube root of x is x to the power 1 over 3. In the same way, nth root of x is x to the power 1 over n. In the same way, it is a fifth root, so it is the power 1 over 5. Now we have two terms, a is to the power 4 and b is to the power minus 3. So it will be a is to the power 4 to the power 1 over 5 multiply b is to the power minus 3 is to the power 1 over 5. Now we can see 4 and 5 we cannot cancel, minus 3 and 5 we cannot cancel, so we just multiply 4 by 1. So a is to the power 4 over 5 multiply b is to the power minus 3 over 5. If we compare it with the a is to the power x multiply b to the power y, we can say that a is equal to 4 over 5 and b is equal to minus 3 over 5. That's all for today in the rule of rules of indices. I hope you have got the idea how to solve the questions. It's easy. See you next time with a new topic of C1, that is expanding expressions. And don't forget to subscribe my channel. If you have any question, kindly send me a message. I will definitely reply to you. Thank you.